Alright, before I force myself to do real work today, I want to do something here with this. I think my transformer is shorting out, and maybe this video will prove that. Right about 16 volts input. This is what's happening when you hear that. We have this distortion when this doesn't snap all the way back. See, it's a nice clean signal, bam. When it does not, that energy is transferred, I guess, to that 12 volt rail. It's like a feedback or maybe something of that nature. But yeah, you can see the pulses that are basically where they are. They're nice and clean, where this one they couple or whatever happens, and noise, clean, noise, noise, clean, clean. What is this? Look at this at 6.6 volts per tube. Peaks at 40 volts. But yeah, ultimately, we see opposing polarity there, but not necessarily equal opposite, and that's, I believe, primarily because we only have the bifilar secondary connected with a diode, so we're basically missing an entire inductor on one side of it. And I believe that if we, as our previous video showed, balance that inductance per just one coil of this bifilar secondary, that would allow for the equal opposite polarity, meaning increased magnetic force, stress in the cell, higher voltage perhaps, lower amperage. I think this is actually shorted out. Pushed it a little too hard.
Well, boys, I fucking sent her a little too fucking hard, but I really hope oh, fuck, bud.
And I would love to be able to have these custom wound with an additional winding equal to the inductance of the secondary's negative terminal. And I think that would provide perhaps an insane transformer right there. Maybe with a little bit more insulation between the primary and the secondaries. Do any of y'all have a toroidal transformer winder? Yo, if any of y'all have a toroidal transformer winder, I will pay you monies. Let me use it, please. Help me. Alright, I gotta go get some real work done before I don't. My real job calls. I'll do this one more time just because I love it so much.
Welcome to Season 4 of Stan's Revenge. A new exciting chapter awaits. My name is Noah Almond. I've been experimenting with Stanley Meyer's water fuel cell technology for over 14 years. In previous seasons, I've made exciting discoveries in his technology, namely the operation of the electrical polarization process. This is unlike traditional DC electrolysis where low voltage and high amperage is utilized. As always, no electrolyte or additives are used in my cells. Only ordinary, natural water is utilized. In this season, I pushed the boundaries of my water fuel cell technology further in my latest attempt to break the glass ceiling of 150 volts. Join me as we unlock the secrets. This is Stan's Revenge.
Alright, so I've got this basic toroidal inductor calculator here. These are some very rough numbers here. And it looks like I'm going to have to wrap about 150 turns. I'll probably be 200 just to make it safe, and we can unwind from there. To get the inductance of 220, which would mimic one of the coil sizes on that thing, to hopefully put it in the circuit to balance that equation to see what it does with the waveform from there. Alright, I've chopped all the corners off of this spool right here so I can fit it through this thing and wind it up. Okay, wound up this new coil outside of here. These coils here, this thing's still on. Wound this guy up here. I'm still about half the inductance that I want to be, so I'm going to have to wind this around all the way again once. This was 100 winds, sorry, 200 winds total. It's probably 400 winds total. Let's take a look at this real quick. Maximum voltage we can reach right now. 38, nice. 37, it settles to about 36 volts at 8.4 amps frequency and all that. This is the waveform I'm getting. Let's hook up this inductor. We'll hook it up to the positive side first. Still 8.7 volt or 8.7 amps consumed. Similar waveform, great production. We're down to 1.4 amps. We're only able to achieve about 31 volts. Reversing the inductors drastically slashes input amperage. Different waveform altogether. 1.6 amps through the cell, 32 volts, 33 volts. Decent, but man, these cells are still performing appropriately for that voltage level. I switched the inductor on the other rail. A little bit better voltage. Good waveform. You see how it's becoming balanced here. We now have a negative potential and positive potential. Not completely balanced, but better. 8.8 amps consumed. 31 volts leveled out here. 1.4 amps at the cell. Switching polarity of that inductor. Four amps consumed. This is my waveform, not balanced in any way, but 32 volts there, still same frequency and all that, but 4 amps ain't bad, not bad at all for 32 volts at a single cell. Switch the polarity back to previous. I do love the equal opposite polarity better. Look at that. Yeah, not bad. Not bad. I enjoy the amp savings of the other way though. But I like that waveform better. Okay, now look at this. If my battery does not die. I've got this now wired in a bifilar, the inductor wired on the bifilar mode. I have it on the negative end of this thing. I've got the diode on the negative end of this thing. And current respective to that. Now look at amperage at the cell. Oh, no, it was bugging out. Never mind. I am, however, getting very nice, much more equal opposite polarity pulses in this configuration. I really like that.
This is Stan's Revenge.